In a world where human ingenuity is often praised, there are few achievements as celebrated as the creation of structures meant to stand the test of time. One such feat was a bridge that was hailed as the Unbreakable. Engineers, architects, and the general public alike believed that this bridge, with its revolutionary design and advanced materials, was impervious to failure. It was a symbol of engineering perfection, a testament to what humanity could accomplish with enough ambition and expertise. But what happens when something thought to be indestructible collapses in seconds? The world was about to witness this very spectacle, as the so-called unbreakable bridge would break like paper in less than 40 seconds, exposing critical flaws hidden beneath its seemingly flawless exterior. How could this happen? How did a structure built to endure countless stresses, weight, and natural forces crumble in the blink of an eye? To understand the answer, we must first explore the myths surrounding this bridge, myths that were built on overconfidence, incomplete knowledge, and a misplaced trust in the very materials that were supposed to ensure its safety. But the collapse was not just a failure of design, it was a humbling moment that shattered the myth of invincibility in engineering. In the following moments, we'll dive into the very heart of this disaster, looking at the design, the expectations, and the shock of what happened when those expectations were shattered. So, how did this seemingly indestructible structure fail so catastrophically? Stay with us, because the answer is as surprising as it is tragic. If you're enjoying this video so far, we'd love to hear your thoughts. What do you think went wrong with the Unbreakable bridge? Share your theories in the comments below. Did you know that this collapse shook the world of civil engineering to its core? If you're intrigued by this story and want to keep diving into more engineering disasters, make sure to hit that like button and subscribe to the channel. Your support helps us bring more stories like this to light, uncovering the hidden flaws in our world's most famous structures. Now, let's move on to the next part of this tale, where we'll uncover the design and the engineering that once made this bridge seem invincible. To fully understand the catastrophic failure of this so-called unbreakable bridge, we must first explore the very elements that made it a marvel of engineering at the time. Situated in a strategically important location, the bridge was designed to withstand the harshest conditions, connecting critical points for trade, transport, and defense. The location itself, often subjected to extreme weather and heavy traffic, made the construction of such a robust structure not just an ambition, but a necessity. But what set this bridge apart wasn't just its location, it was its design. Crafted with cutting-edge materials and incorporating innovative engineering techniques, the bridge was considered a masterpiece. At its inception, engineers boasted that it could withstand forces no bridge had ever been able to endure before. The materials used were selected for their strength and resilience, touted to be almost invulnerable to the pressures of daily use and environmental wear. The main structural design utilized a combination of reinforced steel and newly developed alloys, creating a solid framework that was believed to be impervious to the ravages of time. Furthermore, the construction techniques were a leap forward for the industry. The use of tension cables and reinforced supports had been tested and proven in smaller-scale projects, and this bridge was going to be the proof of their power when scaled to monumental proportions. Experts believed they had eliminated the potential for failure after all. The best minds in engineering had given their seal of approval. But what happens when the very things you trust the most, the materials, the design, and the calculations, fail? As we look deeper into the bridge's specifications and the way it was built, we begin to see the cracks in what was thought to be perfection. Despite the brilliant minds behind its creation, certain fundamental flaws were left unchecked, waiting to reveal themselves when the bridge was tested in ways no one anticipated. The day of the bridge's collapse began like any other. Cars and trucks rumbled across its span, the hum of daily life echoing through the steel structure. The bridge, which had withstood countless heavy loads over the years, was seen by many as invincible, a monument to human achievement. But on this particular day, something was different. It was a normal morning, with nothing to suggest that the unbreakable bridge was on the verge of destruction. Yet, unbeknownst to everyone, the stresses on the bridge were beginning to push it past its limits. The load-bearing weight, the traffic, the weather reach factor was compounding in ways that had not been anticipated, even with the most advanced engineering. As the hours passed, engineers and workers on site went about their tasks, some even boasting about the strength of the bridge, laughing at the notion that it could ever fail. The day seemed like any other until, suddenly, the unthinkable happened. At precisely 10:30 a.m., the bridge began to shake, just slightly at first. It was subtle, almost imperceptible, and the few people who noticed thought it was just a minor tremor, but within seconds, the vibrations intensified. A deep rumbling sound filled the air as the structure began to buckle, steel groaning under immense pressure. The air became thick with panic. Those on the bridge had only moments to realize what was happening. The very structure that had been celebrated for its unshakable design was beginning to collapse slowly at first, and then all at once. Within 40 seconds, what had been declared indestructible was reduced to rubble, as the once heroic bridge crumbled under the weight of its own design flaws. The sound of the collapse echoed far beyond the immediate vicinity, a horrifying testament to how quickly something believed to be unbreakable could come undone. As the dust settled and the aftermath of the bridge's collapse unfolded, engineers and investigators began the painstaking task of determining what went wrong. The bridge, once thought to be the pinnacle of modern engineering, had failed in a spectacularly devastating fashion. What caused the unthinkable to happen? What were the critical failures that led to the bridge's demise? The first glaring issue was the overconfidence in the materials and design. While the bridge was constructed with advanced steel alloys and reinforced with tension cables, these very materials were not tested to the limits they would face. The bridge's design, which seemed flawless on paper, had overlooked crucial factors that would become evident only under conditions. One key issue was the underestimation of dynamic loads forces that occur when large numbers of vehicles travel across the bridge at once. Although the bridge was designed to support heavy traffic, it was not equipped to handle the constant shifting of weight that occurred during peak hours. The materials, while incredibly strong individually, had been compromised by the constant strain of these shifting loads over time. Another failure was related to the environmental stresses the bridge faced. Although the bridge's design accounted for factors like wind and rain, it was not built with the knowledge of the extreme temperature fluctuations that would affect its materials over the years. The steel, although resilient, expanded and contracted in ways that were never anticipated, gradually weakening the structure. Finally, human oversight played a role. While the design process had been thorough, there was a failure to account for long-term wear and tear. Routine inspections and maintenance were not enough to catch the small but significant faults that had developed over time. Engineers had placed too much trust in the idea that a structure of such magnitude could not fail, without considering the impact of minor yet critical errors in the materials and construction. The combination of these factors, miscalculations in load-bearing capacities, neglect of environmental factors, and human error, created a perfect storm. In the end, it wasn't just one fatal flaw that caused the collapse, but a series of interconnected failures that all led to the same tragic result. The collapse of the bridge not only sent shockwaves through the engineering community, but also left a lasting impact on those who witnessed it firsthand. Eyewitnesses describe a scene of panic, confusion, and disbelief as the once proud bridge crumbled in seconds. To truly grasp the magnitude of the disaster, it's essential to hear the voices of those who were there, who saw the collapse unfold before their eyes. One such eyewitness was a traffic officer stationed at the entrance to the bridge that fateful day. "At first, I thought it was just a tremor, a small shift," he recalls. "But then, it became clear that something was terribly wrong. The whole structure started to sway, and people began screaming. I could see the concrete cracking, hear the sounds of the metal twisting. I don't think anyone truly understood what was happening until the first section of the bridge fell." Voice trembles as he describes the chaos that followed, cars veering off the bridge, some tumbling into the water below, while others screeched to a halt in a desperate attempt to escape the falling debris. For engineers and workers who had been on site, the collapse was equally horrifying. One construction worker who had been overseeing maintenance on a section of the bridge that day said, "I was just a few hundred yards away when it started. I heard the metal groaning, like it was alive. At first I thought it was just a malfunction, something we could fix. But then the whole thing started to come apart. We tried to get everyone off, but it was too late. It was over in less than a minute." His eyes are haunted by the memory, a reflection of the helplessness felt by so many that day. Another eyewitness, a truck driver who had been crossing the bridge at the time of the collapse, recounts the terror as the bridge gave way beneath him. "I was halfway across when the whole thing started shaking. It felt like the ground was splitting open. I tried to hit the brakes, but there was no stopping it. I saw cars fall, people screaming. I thought I was going to die right there. Somehow, I made it off just in time, but I'll never forget the sound of the concrete breaking, the noise of it all. The overwhelming sense of disbelief in the moments following the collapse was shared by everyone present. Many couldn't fathom how something so solid, so permanent, could simply fall apart. As one witness put it, it was as if we were all in a nightmare, watching the world's strongest bridge turn to dust in front of us. No one could comprehend how it happened so quickly. In the aftermath, as rescue teams scrambled to aid survivors and recover bodies, the haunting accounts of those who were there revealed just how deeply the event had shaken those who were part of the engineering community and the general public alike. The image of the bridge falling, the massive structure crumbling like paper, would be seared into the minds of all who had witnessed the collapse. As the dust settled and the scale of the disaster became clear, a crucial question arose. Could this tragedy have been avoided? Investigations into the collapse revealed that, while engineering flaws played a major role, human error and miscommunication were just as significant in bringing the unbreakable bridge to its knees. One of the primary contributing factors was the assumption that the bridge, once built, would be virtually invulnerable. This assumption led to a sense of complacency in maintenance practices and oversight. Engineers, confident in the bridge's initial design, failed to consider the long-term stresses it would face. There was a collective belief that regular inspections and maintenance would be sufficient to keep the bridge in working order. However, the design flaws that became apparent in the wake of the collapse were present for years, and they were never fully addressed. Another major issue was the lack of effective communication between the engineers, the construction team, and the workers responsible for maintaining the bridge over the years. Vital information about the bridge's design weaknesses was either overlooked or downplayed, leaving many key players unaware of the bridge's true vulnerability. This lack of communication resulted in decisions that ignored warning signs and led to critical oversights. One engineer, who was involved in the maintenance of the bridge in the years leading up to the collapse, Tiffs admits, "There were moments when we discussed some of the potential issues with the design, but it was always put on the back burner. We were under pressure to keep things running smoothly. There were so many systems in place to maintain the bridge, but we didn't take the time to examine the bigger picture." It wasn't until the collapse that I realized how much we had missed. On the day of the collapse, human error and miscommunication were evident in the minutes leading up to the disaster. One key moment of failure occurred when a team of workers received conflicting instructions regarding the safety of the bridge's load limits. Some engineers argued that the bridge could handle more weight, while others insisted it should be unloaded. The lack of agreement created a delay in critical decision-making. This indecision, paired with the growing strain on the structure, set the stage for the final breakdown. The situation was made worse by a lack of proper emergency protocols. The workers who were on site during the collapse had no clear plan for dealing with a sudden structural failure. As the bridge began to buckle, panic spread quickly, and confusion reigned. Had there been a more effective communication system in place, the workers may have had the opportunity to evacuate or implement safety measures in time. In hindsight, it's clear that miscommunication and human error played a significant role. In the collapse, the engineers were overconfident, and the workers were left without clear guidance. The result was a catastrophic failure that no one saw coming, despite multiple warning signs that had been ignored or dismissed. The collapse of the Unbreakable Bridge left devastation in its wake. The immediate aftermath was a scene of chaos, confusion, and disbelief. Emergency responders, engineers, and rescue teams scrambled to assess the damage and rescue survivors, but the magnitude of the disaster quickly became apparent. What had once been a symbol of engineering triumph had now become a tragic reminder of human fallibility. As the dust settled and the wreckage was cleared, the scale of the destruction was revealed. Sections of the bridge had fallen into the water, with debris scattered over a wide area. Several vehicles that had been on the bridge when it collapsed were submerged, and emergency teams worked tirelessly to pull survivors from the wreckage. In the days that followed, the death toll would rise, with many victims lost in the wreckage or drowned in the waters below. In the midst of this chaos, one of the most striking reactions came from the public and the media. The bridge, once hailed as unbreakable, had been a source of pride for the community. To see it reduced to rubble was a shocking blow to the collective confidence in modern engineering. News outlets flooded the airwaves with stories of the collapse, with some questioning the very foundations of the engineering principles that had been used to design the bridge. How could something built with the best materials, the most advanced technology, and the expertise of the brightest minds fail so catastrophically? For the engineers who had been involved in the bridge's design, the collapse was a professional and personal crisis. Many of them, once proud of their work, now found themselves grappling with guilt, shame, and disbelief. Some engineers openly admitted that they never thought the bridge would collapse, but as they began to review the evidence and the failures that led to the disaster, they realized how certain oversights and assumptions had led them astray. The aftermath also saw an outpouring of support from the public, as rescue teams worked around the clock to recover bodies and provide aid to survivors. Communities rallied together, offering shelter, food, and support to those affected by the collapse. Yet, despite the heroic efforts of the rescue teams, it was clear that the emotional toll of the event would linger long after the physical damage was repaired. Amidst the tragedy, there were also questions of accountability. Who was responsible for the design flaws and the miscommunication that had led to such a catastrophic failure? In the months that followed, investigations were launched, and legal proceedings began. The aftermath would be marked not only by the physical recovery of the site, but by a deep, introspective examination of what went wrong and how to prevent such a tragedy from ever happening again. In the wake of the collapse, an intense investigation began, aimed at uncovering the causes behind the destruction of the Unbreakable bridge. What started as a routine assessment of a structural failure soon turned into an extensive examination of both human and engineering shortcomings. Experts, engineers, and investigators from around the world came together to piece together the mystery of why this bridge, considered a feat of modern engineering, had failed so catastrophically. The first thing the investigators noticed was the initial underestimation of the potential stress the bridge would endure. Despite being designed to handle substantial loads, the bridge had not been evaluated for the long-term cumulative effects of constant wear and traffic. It became apparent that the weight-bearing capacity, though theoretically sound, had been overestimated during the design phase. The rapid growth in traffic volume over the years had placed far more strain on the bridge than anticipated, and no one had accounted for the long-term degradation that would result from this constant usage. However, the most shocking revelation came when investigators examined the bridge's construction process. It was discovered that certain shortcuts had been taken during the build, driven by the desire to complete the project ahead of schedule and within budget. Some of the structural components that had been designed to withstand immense forces were not properly reinforced or placed in a way that ensured their longevity. Critical junctions where weight was transferred between sections were found to be under-engineered, contributing to the catastrophic failure when the bridge was subjected to excessive load. What seemed like small, inconsequential decisions at the time had culminated in a disaster waiting to happen. The use of cheaper, less durable materials in some of the non-essential parts of the bridge, like the outer supports, was another key factor. Although these decisions were not directly responsible for the collapse, they played a significant role in weakening the structure over time. The failure of these seemingly insignificant components triggered a domino effect that ultimately led to the collapse of the entire bridge. Additionally, the investigation revealed lapses in communication between the engineers who designed the bridge and the workers who were tasked with its upkeep. Maintenance procedures had been largely mechanical, relying on routine inspections without fully considering how the constant stress and wear might be, weakening the structure in unforeseen ways. There was a serious lack of collaboration between the engineers who built the bridge and the maintenance teams who operated it. While engineers had designed the bridge with a theoretical worst-case scenario in mind, maintenance teams failed to identify and address the accumulating stresses caused by daily usage. In the aftermath of the investigation, it became clear that the collapse wasn't the result of a single mistake, but rather a combination of design oversights, poor communication, and a disregard for long-term sustainability. The findings of the investigation would not only change the way bridges were designed and built in the future, but also serve as a painful reminder that overconfidence in engineering, no matter how advanced the technology, could lead to disastrous consequences. The collapse of the Unbreakable bridge became a pivotal moment in the field of civil engineering. The investigations into the causes of the disaster revealed crucial lessons, not just for the engineers directly involved, but for the entire industry. In the aftermath, several key takeaways emerged that reshaped how bridges and large infrastructure projects in general are designed, built, and maintained. First and foremost, the disaster underscored the importance of long-term planning and sustainability. The overconfidence that the bridge's initial design would withstand all foreseeable stresses without accounting for the accumulation of traffic and wear over time was a major oversight. Engineers learned that infrastructure projects cannot merely be designed for the ideal situation at the moment of construction. Instead, they must be flexible enough to adapt to changing demands and unforeseen factors, such as increased traffic or environmental changes. The bridge's failure served as a stark reminder that long-term monitoring and adaptive design modifications are essential to maintaining the integrity of any large-scale project. One of the most important lessons was the need for a holistic approach to design, one that takes into account not just the theoretical load capacity, but also the real-world factors that might affect the structure over time. It became clear that the combination of materials, environment, and ongoing use must all be considered as part of the overall design. Engineers realized that every material, from steel to concrete, behaves differently over time, especially under constant stress. The failure to account for this made the bridge's eventual collapse almost inevitable. The failure of communication between engineers, construction workers, and maintenance teams was another key takeaway. The lack of collaboration and a shared understanding of the bridge's vulnerabilities prevented crucial issues from being identified and addressed. Early on, engineers and workers had operated in silos, each group focused on their own tasks without considering the overall impact of their decisions on the structure's long-term viability. Going forward, the importance of cross-disciplinary collaboration became clear, with engineers and maintenance teams being trained to work together and identify potential problems before they became catastrophic. Another significant lesson was the realization that oversight and routine inspections were not enough. While routine maintenance had been carried out, it was clear that the bridge was not being properly evaluated for the stresses it had been subjected to over time. Engineers and maintenance teams learned that regular inspections must be more thorough and more focused on detecting potential vulnerabilities caused by prolonged wear. The use of advanced technologies, such as sensors and structural health monitoring systems, became a priority in ensuring the early detection of any damage. Finally, the collapse highlighted the need for engineering humility and continuous learning. The engineers behind the bridge's design, although highly skilled and respected, had allowed their confidence in their work to blind them to the potential for failure. The tragedy forced the engineering community to confront the limits of human knowledge and expertise. While technological advancements had made incredible feats of engineering possible, the collapse showed that there was always room for improvement. No structure, no matter how well designed, is impervious to failure if proper precautions and continuous evaluations are not in place. In the wake of the collapse, the industry saw a significant shift toward more rigorous testing, flexible designs, and ongoing evaluation. These lessons have since been applied to countless other infrastructure projects, ensuring that future bridges, roads, and buildings are safer, more durable, and more adaptable to the changing demands of the world around them. The collapse of the Unbreakable Bridge remains one of the most tragic and instructive events in the history of civil engineering. It is a stark reminder that even the most seemingly invulnerable structures are susceptible to failure, if not carefully designed, maintained, and regularly evaluated. The disaster was a turning point for the engineering world, reshaping how large-scale infrastructure projects are approached, scrutinized, and ultimately protected. In the years that followed, the lessons learned from the collapse were implemented in every major engineering project. More stringent safety protocols, more rigorous design tests, and better communication between engineers, construction teams, and maintenance workers became the new standard. The failure of the bridge sparked a wave of innovation, leading to the development of new materials, technologies, and methodologies to improve the resilience and longevity of infrastructure. But beyond the technical lessons, the legacy of the collapse also lies in its human impact. The disaster left a lasting mark on the families of those who lost their lives and the survivors who were forever changed by the events of that day. For them, the collapse was not just an engineering failure, but a personal tragedy that would shape their lives in ways that no technical analysis could ever fully capture. As we reflect on the legacy of this disaster, we must also consider the ongoing importance of learning from past mistakes. Every bridge, every building, and every piece of infrastructure that we build today stands on the shoulders of those who came before us. The collapse of the Unbreakable Bridge serves as a cautionary tale, reminding us that even the most monumental human achievements are not beyond failure. It teaches us to be humble in the face of progress and to always question, test, and improve the systems we create. For engineers, architects, and construction workers, the collapse reinforced the importance of vigilance, foresight, and the understanding that perfection is an ongoing process, never a final destination. While the bridge may have failed, the lessons it taught continue to drive the evolution of safer, more reliable infrastructure. As we move forward, we must remember that the true strength of any bridge, whether physical or metaphorical, lies not in its supposed invulnerability, but in its ability to withstand the pressures of time, use, and unforeseen challenges. The collapse of this once unbreakable bridge reminds us of the fragility of even the most impressive creations, but also of the resilience of those who learn from failure and strive to build better, safer futures. If you've made it this far, thank you for sticking with us through the entire story of the Unbreakable Bridge. What do you think? Do you believe more stringent regulations could have prevented this disaster? Or was it just an inevitable consequence of engineering limitations? Let us know your thoughts in the comments below. If you found this video insightful, don't forget to give it a like and subscribe to the channel for more deep dives into historical engineering failures and the lessons they taught us. Your support helps us keep telling these important stories. Also, we'd love to hear from you. If you've ever been affected by a disaster or have any personal experiences with engineering failures, feel free to share them with us in the comments. It's stories like these that remind us of the importance of continuous learning and vigilance. And before you go, make sure to check out the next video on the screen. It's another fascinating look at a major historical event that changed the world of engineering forever. See you there.